All right, ladies and gentlemen, good morning to you guys. I apologize. Hope you guys are doing well. Give me a like there if you can hear me, and hopefully you guys can hear me. We'll move things over here. Get things in its right place. So let's get those likes coming on in. It says you guys can hear me, so. All right, looks like the likes are in. Okay, thank you guys so much. Give me a few seconds here. I'll be with you guys in a few minutes, or not in a few minutes. I'm just saying in a few seconds. Let's go on over to the browser here now and check out the speed test. See how things are going now. All right, ladies and gentlemen, it looks like we're good at 39 megabits per second. So set things to, let's go over here. Google Chrome, set things in your and here as I get rid of some of these other things. Set YouTube to 1080p to maximize your experience. So, ladies and gentlemen, let's continue with the browser here. And no, we don't want to go there. We want to go here. And I want to let you guys in on a little bit of information here. Hopefully you guys are there. We're going to go to the assignment portion, and let's go over here. I have put up here a sort of tentative. Did I put it up? Should be there. Let's hit refresh. I did put it up. Well, let me double check here. Let's look for files. Yeah, I don't think I did put it up yet. Well, I'm working on, let's just say I'm working on your study guide and your test 4. I guess I'll make an announcement about all that tomorrow on Thursday for you guys. And, I'll get that up. I think it is ready for the most part, but, let me see if I could get that kind of up now since we're on the topic so you guys can start to be aware of this. So I'm going to upload 241 test 4 final exam study guide. I think I do have to change the name here for you guys there. And there we go. So we're going to go to 241. We're going to go to this file here. Give you guys some information. File. Well, we'll call it now for the most part, and that's not what I wanted to do, but I'll get this up for you guys. For this second here. Yeah, let's do this here. Let me print this here. Save as a PDF. So I'm gonna do it now. Test 4 and final exam study guide. Okay. And print this, save it as a PDF. You guys can't see this. All right, and I'm going to get rid of this. Go to the Files section. Come on, Files, where are you? Okay. Turns out I have to delete these things to fix it. And this is what I'm looking for. All right. Okay, so hopefully you guys are here. And if you are, it's a good thing because what I'm about to share with you guys here is some important information here. We're working on your test 4 and your final exam study guide. Okay, so if we go back to the course here, and we got to go to 241, worksheets and videos here. Go back to 241. Schedule. So on Monday, December 6th, we have our test 4. Now, here's what I've designed things to be in case you guys didn't know. If you said, wow, I have that test 4, and the next week I'll have a final exam on the 14th. And I'll say, yes, you do. Yes, you do. You got test 4, and then you got your final exam. But what I'm going to do now here, ladies and gentlemen, is I'm going to share with you a couple of things here. Your test 4, when I typically give a final exam, when I typically give a study guide, I don't have people turn it in. But what I'm going to do now here is this. I'm going to give you guys that final exam, test 4, study guide, blah, blah, blah. It's titled test 4, and it's also titled final exam study guide. So I have some information here that I might change, by the way, just to let you guys know. It's a bit long, but this is going to be like a final exam study guide I want you guys to do. and you're going to turn that in. This is going to be your test 4. So later today, I might modify and change, and I'll let you guys know. But I wanted to at least get it up there for you guys to take a look, to consider. And this is, again, some things that you want to work on now. Now, it's not due on Monday, though. It isn't due the day of test 4. It's due the day of your final. So this test 4, even though it's scheduled here on Monday, December 6th, that's when it's scheduled. It's not due until your final exam day. So it's like 2 weeks, essentially. A couple of weekends, 2 weeks. And like I said, I think I might change some things on that just so you guys know. Some things can be quick and easy. Some things, you know, just to kind of inform you guys about it now so that you guys are aware and it's there. So I hope you guys find it helpful, because you guys could get started on it ASAP. And this will even prepare you for your final. Your final won't be as long as that study guide, and it's also called Test 4, but it'll prepare you for your final. So like I said, I did upload that for you guys there. Here it is. It's in Canvas, so you should see it now. And we're going to talk about some of these things. Most of these things we've already talked about, but not everything. So we're going to have to fill in the gaps here in the next 2 weeks, and then that'll help prepare you for your final. And that's the idea. So here's where we're at, ladies and gentlemen. We're preparing for Test 4 in that final. Your Test 4 will be simply turning in this final exam study guide on the day of your final. And the day of your final is going to be Tuesday, December 14th from 7 to 9 a.m. That's when you guys turn this in. Anyway, so you could get started now if you like. And, I'm going to get started on some topics that we want to cover. And those topics that we want to cover, ladies and gentlemen, it's over here. We're going to talk about vectors. Okay? Vectors are very important to science and mathematics. Vectors. And when you see a vector, ladies and gentlemen, I want you guys to know one thing. This is an arrow. It's an arrow. And you go, what do you mean it's an arrow? Yeah, well, it looks like an arrow. It's actually technically a ray here. And a lot of times we have 2 points here, A and B. But this is called a vector. And I want you guys to know two very important things regarding vectors. Vectors have 2 aspects. Okay. And I'll write it as a definition because a lot of times, here's what a vector is. A vector is an object that has magnitude and direction. Okay? So this is really what a vector is. It has magnitude and direction. This is the definition. And the 2 things we really have to talk about in detail is this thing known as magnitude and this thing known as direction. Wrong button. Okay? Magnitude and direction. So we're going to start talking about vectors. Now, this is in Chapter 8 still. So it's actually Chapter 8.4. This is where we start on this. We start talking about a vector. Anyway. Okay. Vector. There it is. Let's think about some notation. Very often, since this is really thought of as, in geometry, you kind of have it as a ray, but it's not really a ray. But the notation for a vector is they borrow from geometry. In other words, you got these 2 points A, B, and then you have that arrow there. This is our vector here. Now, this is our initial point. So let me kind of describe this for you. Initial point, terminal point. Initial point and a terminal point. So A is the initial point, B is the terminal point. They define the vector, and every vector has a magnitude, and every vector has a direction. Because remember, take a point, take another point, and this whole thing is known as a vector. This is what's defining our vector here. Okay, here's the notation. Now, I can talk a little bit about, these vectors. Here's a vector, by the way. Let's give you a little bit more of a discussion on a vector. The idea of a magnitude. So if you might say, what does the magnitude actually mean? Well, definition of magnitude. That's also known as it's the length of the vector. So what magnitude means is how long this vector is. And it has its notation. You have this absolute value notation. And all we do is simply put in this vector here. Magnitude, it's the length of this vector. There it is. And that's what you're looking at. So every vector has a length. You can measure how long it is. Also, by the way, you might say direction. What do you mean by direction? Well, it's pointing in a particular direction. And what we're going to look at shortly here is, for example, if you had a horizontal, you have some angle theta. Remember, this is your horizontal. An imaginary horizontal line. When you have an imaginary horizontal line, we call that horizontal, and there it is. And there you go. So we have this vector, we have this magnitude, and this has a direction theta here. So, all right, now let's start to get some ideas here. We have what's called a component form of a vector. And this is where all the trig comes in. So if I give you guys here an XY plane here, we can start to define this component form of a vector. Okay, so let's kind of look at this, what we call a component form. We need 2 points though. We need A and B. So if, for example, this is point A, and point A has an address. That's -2, 1, 2, 3, 4. Here's the location, -2, 4. And I'll say this is point B over here. Point B has an address. That's at 5, 8. This is point B. We can define now the vector by drawing an arrow. Okay, so this is first of all the graph of this vector. We're looking at the graph. This is a picture. But this component form here, we haven't described yet. So let me give you a way to describe the vector in what we call component form. Okay, so this is the component form version of a vector, so I'm going to have to give you another definition. Component form. I guess we can say A is the initial point, and I guess we can call that your first point. Here's what we can do. Let's do it this way. I'm going to do it a little different than your book so you guys know what I'm talking about. Here's my first point, right? Location A. So A and B. Here's the second point. A and B are 2 points in a plane. Okay, so this is the points we're talking about here. A and B. So you got 2 points in a plane called A and B. Then your vector AB in component form is described this way. You're going to take the difference between the x coordinates and the difference between the y coordinates. Okay? And this is how we define in component form any vector when you're given an initial point and a terminal point. So notice this is the initial point. And the terminal point. Okay, so I guess if you wanted to see colors, here's x1 and x2. This is where that difference goes. And y2 and that y1, these values. And then you say, how come it has these brackets here, these sort of, it looks like these are inequality symbols, and that's just notation. Well, this is going to distinguish between a point and what we call a vector, right? This is the vector format. And sometimes we also say, by the way, I'm going to move this down. We also do something like this. We let the letter V represent vector. So we have V here. And there's vector. And this is the component form of a vector. This is what we're going to use here. Okay, so we're going to have to define that vector. So in this example, if you want to call this V, you say, well, how do we do this? Well, we take the difference here between the second point and the first point. So there's a difference there. So this is 5 minus -2. And then you take a difference between 8 and 4. So this is 8 minus 4 here. And ladies and gentlemen, this is going to give us 5 plus 2 and 8 minus 4 are simply the vector 7, 4 here. So here's our new vector 7, 4, ladies and gentlemen. This is what we call the component form of a vector now. Now, I want to say something about this component form because once you get a component form, you know, it has some meaning here. If you look at this vector here, 7, 4 now, this is my vector in component form. If I were to plot the component form here, we say 1, this will be where 7 is. down here. And then 4 is up here. 1, 2, 3, 4, it looks like. Okay? This is location 7, 4, by the way. I can draw this arrow at the origin, and what you're seeing here is a representation here of the same exact vector. In other words, the vector here that we already described in blue is equivalent to the vector in red, because what we can do with vectors is we can simply move them around, okay? Because remember, what's a vector? A vector is an object in a plane that has both magnitude and direction. So the blue vector that was given to you and the red vector, notice they have two things in common. They have the same length, same magnitude, and they have the same direction. In other words, they're pointing in the same direction. So here's what they share. They share the same magnitude, and the same direction. And that's an extremely important detail. That means these are the same exact vectors. Okay, so let me say this to you guys here. Give you guys a fact here, or a definition. I'll say, we say vector V and vector W are the same vectors. They're equivalent. If they share the same magnitude and direction. So you're looking at the blue vector has the same length as the red vector. It's just one is in component form, and this is how we start to get a handle on vectors. But the idea is to convert every vector to component form. And in component form, you know, we can graph that, but component form has that initial point really being at the origin, 0, 0. So we can put that in red, so we emphasize this idea. And then that terminal point is at 7, 4. These are the same exact vectors. This is actually why we get them in component form. And that's essentially, you know, what we want to do. So what I'm going to do now here is this for us, ladies and gentlemen. Give you guys another example of this. And what we want to do is describe our vectors in component form. Okay, so we're going to give you 2 points again. A is going to be the point 0, 2. B is going to be the point negative 1, 1. So we'll give this, we'll call this example, I guess. And we're going to get started on working with these vectors. So when we plot 0, 2 for A, right, 0, 2 is right here. So this is the location for A. Negative 1, 1, to the left 1, to the right 1. This is B here. So you have this little arrow, and this is going to be my 2 vectors here. Okay, so remember, this is written as AB, the initial point is A, and the terminal point is B. And we very often call that just simply vector v here. So you will see notation looking like this. All right, so here's my picture of that vector. The component form version of this vector now. Component form, right? We'll say that same vector, we start with the x components, the terminal point minus, let's write that down here, -1 minus 0, comma, in green here, 1 minus 2. So vector v now will be -1, -1. And so if we were to plot this here, this component form, what we want to label here, this is the 0, 0. This is my new initial point. -1, -1's the new terminal point, and I just draw the arrow. And what I am saying to you is two things again. That those two vectors here that you see, the blue vector and the red vector, they're equivalent because they have the same magnitude and they have the same direction. And the reason we look at this component form is because this is the form in which we're going to start to work with, mathematically. So our first exercise, ladies and gentlemen, is to, we're gonna look at these component forms here. Oops, there we go. Now, here's another thing we want to describe here. Now you might say, okay, well, what about this magnitude and direction idea? Every vector has a magnitude and it has a direction. Okay? So we have vectors, they have magnitudes, they have directions. They do. So how do we determine the magnitude? So I'll give you the definition of the magnitude of a vector. And remember, the magnitude always means the length of your vector, how long that is. So we start by looking at a vector. You can call it AB or you can call it vector V, and then they'll change this on you and they'll say, okay, here's my two component forms. You start with a vector. Let V be a vector. And notice that this is the component form of a vector. Okay, and you say, why do they call it a component form? Because you have components like the x component and the y component. This is why it's a component form. And it's a vector because of the arrow notation and because of this notation here. So here's the magnitude. Here's the definition of magnitude now. The length of that vector is the square root of a squared plus b squared. So here's the length of the vector. This is how we measure the magnitude. Now let me go into some detail as to why we measure that length here. So if I ask you guys this question here, here's why we measure length, because we're talking about now a magnitude and a direction here, right? Where do you think this comes from? Let me get out my Cartesian coordinate. Right? So I'm going to say this to you guys here. This here is what I'm talking about. If I had vector A here, or this vector, let me try to, this is component A. See if we can get there. The component form version of a vector, it's now in blue, okay? And I'm going to draw this triangle here for us, so I can express to you guys where this comes from. Now, remember this. Down here, this is the length of A. This is the length of B. Then the question is, what's this length? For magnitude, right? So this will be my A value. This is my B value. And from Pythagorean theorem, ladies and gentlemen, that's the C value. So Pythagorean theorem is actually behind the mechanism here. Remember, C is plus or minus square root of A squared plus B squared, or we say C here is really A plus B square root, because distance here is positive here that we're going to define there. We only look at the positive value. But this is how we get this idea here of a magnitude. This is the length we're talking about, and this is absolute value of a vector. That's the length of a vector. This is the magnitude of the vector. So if we start to look at these questions here now, and if I said to you, well, here's the vector that we just got in the last example, right? How do we get the magnitude of that vector? How do we get the length of that vector? Well, very simply, we take the components and we square them, which is the square root of 1 plus 1, or the square root of 2 here. So the length of this vector that we just found here is the square root of 2. This is how long that vector is. That's called the magnitude. The prior vector, you said, what's the length of this vector that we just found? Well, the length of that vector, we just use, again, the Pythagorean theorem. Square root of 7 squared plus 4 squared, which will give you the square root of 49 plus 16 . 59 plus 6 is 65. Double check that. All right, we're going to take the square root of 65 here so we could get the magnitude of this vector, how long that vector is. Let's clear that, clear that. Second square root 65, ladies and gentlemen. And this is, we're going to go to the nearest tenths. Let's double check. Yeah. So this will be approximately, now, if we go to the nearest tenths, 8.1. This is the magnitude of my vector. It's about an 8.1. And there you go, ladies and gentlemen. We're going to get the component form of the vector, and then we're going to compute the magnitude of the vector. So there we go, ladies and gentlemen, magnitude. We'll get to direction, but for now, we're going to do a few things. So give you guys some examples here. Let's ask you guys here. I want you to determine the component form of your vector and its magnitude. Okay, so the first one, we're going to say A here is 3, 0. B here is 6, 7. Question 2. A here is -1, 4. B here is 2, -5. Okay. Question 3. A here is, how about 0, 5. And B here is -4, 0. And I want you guys to also note the following. You also want to graph these here. Graph the vector. So we'll give you guys some time to try this out for yourself. It's a very good exercise. And, you know, this is starting to work with vectors. So it's a good kind of thing to get started on. So ladies and gentlemen, let's take a look here. Okay, ladies and gentlemen, what kind of things did you guys get here for this? Anybody want to talk about it? Right, let's look at the first one here. Let's bring these things in here. Let's add that. So if we plot this point 3, 0 here, right? A is 3, 0. This is 1, 2, 3. Here's your location here. This is where point A is. Point B is 6, 7 now. So we have to go to the right. An additional, this will be 6. We go up 7 now. 1, 2, 3, 4, 5, 6, 7 here. So this is my second point. So remember, we're looking at the following points. 3, 0, 6, 7. And I'm going to draw an arrow. So this vector here, given in terms of coordinates, we're going to find the equivalent component form of that vector. So use your definition here, right? The component form V now is found by taking the final point here, this 6 minus 3. And I'll do it this way. 6 minus 3 here. 7 minus 0. And so my vector V becomes 3, 7. So we go to the right, 1, 2, 3, and we go up 1, 2, 3, 4, 5, 6, 7. So here's my 3, 7. And this is my 0, 0. So it's like if we're moving, ladies and gentlemen, it's like if we just moved the vector that was given this way in blue. In terms of coordinates, we convert it to the component form. They're equivalent because they're pointing in the same direction and they have the same length, they have the same magnitude. So this is the first one that we had to do. 3, 0, and then 6, 7. So there we go, ladies and gentlemen. Did anybody get a length here? What's the length of vector V now? That's the square root of 3 squared plus 7 squared. 9 plus 49. Square root of 58. What's this length? We're going to have to go to the TI now to get the length of this vector. Second square root, 58. And ladies and gentlemen, let's go to the tenths. Thank you, Mike. Length of this vector is 7.6. Outstanding, Mike. There you go. Pretty good. Okay, we haven't gone in the direction yet, but, you know, we have the length here. This is be 7.6. This is how long these vectors are, and they're the same vector, by the way. They thought of as being equivalent. Good job. All right, now let's look at the next one here. Okay, working with vectors. This is the language of science, by the way. You know, you wouldn't have physical science if you didn't have vectors. And this is why it's so important, you know, to study and to talk about here. You know, you don't have science without vectors, ladies and gentlemen. -1, 4, and 2, -5. So -1, 4, -1, 4 here. -1, 1, 2, 3, 4. So here's my -1. Here's my 4. This is the location of A, my initial point. And you say, what about 2, -5? Okay, go to the right now, 2. 1, 2, and go down 1, 2, 3, 4, and 5 now. All right, just so we can label this here. 2, -5, here's where B is. -1, 4 is where A is here. So just draw your line here from the initial point to the terminal point. There's your vector. Okay, but we want the component form so we can find the length there. The component form, we're going to take again 2 minus negative 1. 2 minus a negative 1. Negative 5 minus 4. Two plus 1, that's negative 9. 3, negative 9 is the vector here. So put that arrow here. So if we want to graph that as well, 3, negative 9, we have to go to the right. 1, 2, 3, and then go down 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the location 3, negative 9 as a point is here, but we're going to draw an arrow. The initial point is going to be 0. We got our terminal point, and ladies and gentlemen, as you guys can see here, the red vector is going in the same direction as the blue vector, and they also have the same length here. And that's what we're doing here. The length of this vector now is going to be square root of 3 squared plus negative 9 squared. So the length of our vector here. Let's find out what this is. Let's go to the TI now. Second square root. We'll do it this way. 3 squared plus, put in parentheses, negative 9 and square that. And ladies and gentlemen, go to the nearest tenths. The length of this vector, the magnitude of that vector, is 9.5 now. So there you go, ladies and gentlemen. This is working with vectors here. Welcome to the world of vectors. Welcome to the world of science. This is your language. Let's do the last one, 0, 5 and negative 4, 0. 0, 5, 0, 5, negative 4, 0 here. Okay, 0, 5, negative 4, 0. 0, 5 is simply up 5 units. 1, 2, 3, 4, 5. Here's my A vector. 0, 5. And you get negative 4, 0. Negative 4, 0. So this is going to be 1, 2, 3, 4 here. Here's your B vector. All right. So let's find the component form. So vector V, 0 minus negative 4, 5 minus 0. Oops, let's be careful here. All right, we're going to be careful. Let's do it. Remember how this works. Got to be careful. Negative 4 minus 0. We can't mix up the order. The terminal point, and I think I'm using the wrong color. It's okay. 0 minus 5 now. It's the terminal point minus the initial point. Negative 4, negative 5. So go to the left. 1, 2, 3, 4. Go down. 1, 2, 3, 4, and 5 now. All right. So this will be negative 4, negative 5. And this is my new vector here. This is the V. It's in red. Here's my blue vector. supposed to be pointing in the same direction, and they have the same magnitude. They look that way to me, so I have my component form vector, and now we want the magnitude of it. Square root -4 squared plus -5 squared. So we're going to approximate that to the nearest tenths here. So get out the TI. -4 squared plus -5 squared. To the nearest tenths will be 6.4. So this is, again, the component form of a vector in red and the magnitude of it. And, you know, this is our introduction to vectors, ladies and gentlemen. We're going to get the direction and so on, but first of all, we're going to give you guys some facts about vectors here. We have some algebra facts. Or sometimes we can say arithmetic with vectors. We have what's called vector addition. Okay? Vector addition. Let me go to my website here. Didn't share this with you guys here. We got worksheets and videos. I got vector applications. I think this would be another. Where else? Where's our vector? Polar conversion, graphing polar curves. If you guys remember this, we got graphing, introduction to polar coordinates, polar equation conversion, graphing. I should have a vector addition. Well, here's some vector applications here. So this is what I want to start to talk about. We got this vector addition here for you guys. So here's that worksheet, parallelogram. We have to do the algebra and arithmetic with the vectors before we do some applications, but I want to kind of get you guys a vector addition kind of, you know, let me go back there. If you look at this, maybe I can find vector addition on my files here. Yeah, it's just called vector applications, but and look in the iPad. This is what I want to start to really investigate. This is the geometry of it, but before we go to the geometry, we're going to look at the arithmetic or the algebra version of vectors here. Okay, so we're going to start with two vectors here. This is kind of how they start this process. I'm going to say let U equal, I guess they'll stick with the letters A and B. I'll stick with what the book has. A1, B1, and VB, A2, B2. Be two vectors. Okay, we're going to start with some vectors. So we really have two vectors here, U and V. Then we have some algebra and arithmetic facts that we can do. The number one, we can add vectors together. So algebra or arithmetic, let me show you guys how to add some vectors. We can have what's called a vector sum. Okay, this is going to be an important thing that we do. All you do is take the components. You add the components here. So this first portion is in orange. In other words, you take A1 plus A2. And then you got this B1 and B2. This goes over here. So you have this B1 plus B2. So this is called vector addition. because you're adding vectors. So we can add vectors if we're given two vectors. Similarly, you can subtract vectors. This is vector subtraction. And, you read this left to right. So what you see here is the U vector first. So you're going to look at the U components first. For the U components, this would be A1 minus A2 and B1 minus B2. So here's the components there. So A1 minus A2, B1 minus B2. Reading left to right, you see the U vector before you see the V vector. This is called vector subtraction. So we can add and subtract vectors. And then we have a third arithmetic operation, also known as algebra, is you have C times V. This is called a scalar multiplication. Scalar multiplication. You go, what's scalar multiplication? Well, C here is a constant. A fancy name is scalar. So C is a constant. It's a scalar. So let me show you what that means. Remember, my U vector was A1, B1. All you do is distribute the constant to every component. So in other words, this is scalar multiplication, but distribute the constant. And they call the constant a scalar. So if you wanted to see that and go, okay, what do you mean? This is my constant, right? The constant's inside now. And I think that's B1. Okay. So we can actually do some vector addition or some form of arithmetic here. Okay, so we can call that vector arithmetic or vector algebra. There's also something called vector calculus here. So vector arithmetic or vector algebra. So, for example, they'll say determine the following. Define two vectors for first, ladies and gentlemen. I'm going to say let U be. Let vector U be 2, -3, and vector V be -1, 4. All right, so now they're going to say determine the following. Question 1. U plus V. Question 2. U minus V. Question 3. 6U. Question 4. -5V. And question 5. 6U minus 5V. All right, we're going to do some vector addition. Vector arithmetic. The foundation of science, ladies and gentlemen. Trig is probably one of the most important math courses you guys can ever take. Here we go. U and V here. So U plus V. So let's do that here. u plus v. So start with u. 2, negative 3. Added to vector v now. That's negative 1, 4 here. Okay, so we're going to do a vector sum there. Now remember the definition here. All you have to do is add the components here. Add your components. 2 plus negative 1, comma, negative 3 plus 4. 2 plus negative 1 is 1. Negative 3 plus 4 is 1. And ladies and gentlemen, you have found your first sum of two vectors here. There it is, sum of two vectors. So you're going to determine the following and get this following sum. Similarly, they want the vector difference. So start with vector u like we just had. Vector u is 2, negative 3, but now you're going to subtract vector v now. You're not going to add, you're going to subtract. And then you say, well, how do I do that? You do that with the components. Okay, you do that with your components here now. 2, negative 1, 2 minus negative 1. There's my 2, negative 1. And then I get negative 3 minus 4. So here's my negative 3 component minus the 4, because this is going to be subtraction again. Or I'm sorry, not again, but this is going to be subtraction. Like in the past, we did a sum. First component, sum, second component, you're going to do this vector addition, vector subtraction. So now you just have to do that arithmetic. 2 minus a minus is 2 plus 1. And that's 3. And the negative 3 minus 4 is negative 7. So ladies and gentlemen, you did a vector difference here. You did some arithmetic with vectors. All right, 6u. Now we're going to do scalar multiplication. So you say, what about scalar multiplication? Well, scalar multiplication looks like this. You take the 6 and you multiply it with the u vector. The u vector was 2, negative 3. But remember what you do. You distribute. So for the scalar multiplication here, you take this 6 here. You distribute with the components there. So 6 times 2 is 12. 6 times negative 3 is negative 18. And now, ladies and gentlemen, you got your scalar multiplication as well here. That's 6u. Okay. Negative 5v. Negative 5 times vector v. Remember what vector v was? It's negative 1, 4 here. So the scalar multiplication is negative 5 times negative 1 and negative 5 times 4, which gives you positive 5, negative 20. Make sure you know that this scalar here, this number is multiplied to the components there. And if you rather see colors, you know, here's kind of the colors there, right? And then you have green for the second component. So maybe that helps you to see things a little bit better, and you get your final answer here. And there you go. And then they give you the 6u minus 5v. So ladies and gentlemen, 6u minus 5v, that first vector, 12. Let me do it this way. 6u minus 5v, we can write as 6u plus that negative 5v, because we already have the negative. So the 6u is 12, negative 18 with components. Negative 5v is 5, negative 20 with components. So remember, we just now do our component addition here. Goes here. Our component addition goes here. 12 plus 5, negative 18 plus a negative 20. So you get 17, and a negative plus a negative, you guys know, is a negative. So ladies and gentlemen, this is how you go about doing this kind of exercise with called vector arithmetic, or really vector algebra. So what we're going to do here, ladies and gentlemen, is get you guys started on all of this stuff here. Okay? We're going to go over to the browser. Now, like I said, I'm going to change that study guide probably. The next few days I'll change it, but I wanted to get that out there so you guys can see. But we're going to put some homework here. And this is going to be starting our work with vectors. We'll get back to the other topic that we just skipped, but I wanted to get vectors started. So remember, the key is really your homework that prepares you for everything. So we'll give you 3 to 24 odd just to get started with vectors. And that doesn't make sense. 3 we'll say to 25 odd. Just to get started with your vectors. And ladies and gentlemen, we're gonna be working with some vectors here. It's gonna be on your test 4 and your final. So, you guys can get started on that as soon as possible. I recommend. It's a pretty simple thing to do. It's kind of an abstract idea, but it's the foundation of science. So you want to make sure you give it your time and energy and effort. So, ladies and gentlemen, print your name in the comments section for attendance purposes, and we'll see you guys tomorrow to continue with the world of vectors.